Hey everybody. So it's Thursday night when I'm recording this, and I've looked at the tests or the quizzes that you guys took, and very good scores on this one, as I would hope for on this one. As long as you've been keeping up, it should be pretty easy to figure out the transformations. There was one question was graded incorrectly, so some of you may have a slightly improved score from what it immediately told you when you were finished. It was the absolute value function, and it was moved to the right by 13.5 or something like that. And everybody who had answered that question had the correct answer, but it graded it incorrectly. So I went through and I fixed all of those. And so for those people, and it was maybe about 8 people that affected, you should check it out. The reason I'm making this video is because we need to continue on, get started on the next chapter because we don't want to fall behind. And right now we're doing fine. We don't have to like speed up or anything, but also we can't afford to slow down. Otherwise, we won't get through everything that we need to get through. So um, I've got just a relatively basic lesson for you guys today. I'll try to get through it fairly quickly. The homework assignment shouldn't take you too long, but by doing this, it's going to let us really springboard into the next big idea on Monday. I don't want to save that for Wednesday. We've seen what happens when I try to do a lot of stuff on Wednesday before. So here we go. All right, so the next chapter is all about polynomials. We'll be doing this one. Well, it's going to take us a while. It'll take us into 2021. And most of this chapter about all polynomials is actually about parabolas. And I don't think this is the first time you're hearing the word parabola, but this is. This graph, this shaped graph, something like y equals x squared is a parabola. Well, of course you've seen this. We just did parent function. And this was one of our parent functions. You could look at this and say, ooh, look at that. It's been moved to the right by 2 and down 6. So we could even say that this has the equation y equals, let's see, we'll have to do x plus 2 to move it. Whoops, there we go, the wrong one. X minus 2 squared minus 6, and that would give us this resulting graph. And so we've seen parabolas before. We're going to be doing a lot of stuff with the parabolas. Basic idea for today, as we're looking at graphs and trying to figure out where the vertex is, where the intercepts are. The easy intercept to find is always the y-intercept, because all you got to do is plug in 0. F of 0 is the y-intercept. The second one is a little bit more difficult, finding when the function is equal to 0. Gives you the x-intercepts, the places where the y value is equal to 0. And this is going to be a key one for us today. The vertex is always halfway in between the two intercepts. A parabola is symmetric. So again, that vertex is always going to be halfway in between those two x-intercepts, or sometimes we'll call them zeros. And actually, going back to that slide reminded me, day 2, skipping day 1 of our usual plan for this chapter. I kept it on the assignment sheet just because I thought maybe someone would want to see what we're missing, and if you're really concerned about missing it, you could take a look at it. But I guess I'm asking you to trust me that the stuff we usually do on day 1 wasn't that big of a deal. So anyway, let's take a look. All I have for you today is a few examples. We'll go through, well, we'll see how long this is taking, and I'll just make sure that I do everything that you need to know how to do. I don't even have a spot for the y-intercept because really just plugging in 0. If I plug in 0, we've got 0 minus 5, 0 plus 1, and the y-intercept would be at negative 5. No big deal, and we can use that. What I'm asking you about today on your homework for this weekend is the zeros and the vertex. So the zeros are when this is going to be equal to 0. Don't plug in 0, that's the y-intercept. The zeros, or the x-intercepts, are the values of x that would make it equal to 0. And if it's in this form, we're going to call this the factored form. It's really easy for me to look at this factor and say, well, what value of x would make this equal to 0? 5. 5 minus 5 is 0. What value of x would make this equal to 0? Negative 1. Negative 1 plus 1 would give me 0. If one of these two factors is 0, it doesn't even matter what the other one is, because 0 times anything would be 0. And then the vertex, as I mentioned already, it's halfway in between the zeros. So if this thing crosses the axis at 5 and negative 1, then I know that the vertex has to be halfway in between those, and halfway in between 5 and negative 1 is 2, the average of 5 and 1. And I was just looking at my graph. If you don't look at the graph, you could just add these together and divide by 2. The average of two numbers is them up and divide by 2. And to find the y-coordinate of the vertex, we'll just plug 2 in. If the x value is 2, this function tells us what to do. We're going to take 2 minus 5 and 2 plus 1. We'll see what that gives us. Negative 7 times 3 is negative 21. Did I do that right? Oh, no, I didn't. I didn't think it was that big. 2 minus 5 is negative 3. Negative 3 times positive 3 is negative 9. And so over 2, down 9, we get to that point, which is the vertex. Remember, we also found that y-intercept was negative 5, so I guess we can use that point there. And I can put the symmetric point on the graph also. And then there we go. There is, you'll probably do a better job of drawing these graphs than I do with my mouse. Here we go. There is that parabola. This one's in a different form. This one actually looks more familiar to you after going through the last chapter. You can recognize that this is in the standard form where I've got x squared. X has been replaced by an x plus 2 and then minus 4. So I'm going to move this graph to the left by 2 and down 4. 1, 2, 3, 4. There is the vertex. And I just found that knowing how transformations work. So you all showed me on the quiz that you are doing fine with that. This is where we use that. And then the zeros, well, what value of x is going to make this equal to 0? Well, let's find out. If x plus 2 squared minus 4 equals 0, that means x plus 2 squared equals 4. Just doing a little bit of algebra. And now I prefer to think of this one like this. I'm squaring something and I'm getting 4. So either x plus 2 is equal to 2, because 2 squared is 4, or x plus 2 is equal to negative 2. The stuff inside here must be either 2 or negative 2. So if x plus 2 equals 2, then x equals 0. If x plus 2 equals negative 2, then x equals negative 4. And so those are my two zeros at negative 4 and 0. There we go. Those 3 points should be enough for us to draw this parabola. And by the way, if I had plugged in 0 to find the y-intercept, 0 plus 2 is 2, 2 squared is 4, 4 minus 4, and we would have found that it goes through that point. But we already knew that. All right. Another type of question that you're going to see looks like this. This is not in your transformed form. I can't look at this and figure out, is it moving up, down, left, or right? Now, that plus does mean that the vertex is going to be to the left, but it's not going to be moved up by 15. The way we're going to do something like this is I'm going to factor out whatever I can from both of these two terms. In this case, I've got an x in each of these terms, and also both of the terms are a multiple of 3. So I'm going to factor out a 3x. When I do that, I'm left with x plus, let's see, 15x divided by 3x is 5. And if you're ever factoring, and this is going to be a very common theme of this chapter, If you factor something like I've done here, I've broken this expression into two things that are multiplied by each other, you can always distribute that and make sure that you did it right. 3x times x, 3x squared. 3x times 5, 15x. Looks good. Now, we've got something that's more similar to what we did with the first example. I've got two things that I'm multiplying together to get 0. My zeros are going to be 0 because 3 times 0 is 0, and negative 5 because negative 5 plus 5 is equal to 0. These two numbers make the function equal to 0. And so if one 0 is at 0 and the other one is at negative 5, that means my vertex will be halfway in between at negative 2.5, comma, and now I'm just going to plug this in my calculator. I'm going to do 3 times negative 2.5 squared plus 15 times negative 2.5, and I'm just plugging this in my calculator. I'm going to make sure that I think this looks right. It gave me negative 56.25. That seems pretty big. I'm going to verify that I typed that in right. When I do a negative 2.5 squared, I want to make sure that my calculator is doing that right, that I plugged it in. Ooh, and it looks like I didn't plug that in my calculator right. I did negative 2.5 squared, and I thought that my calculator would know what I meant, but it didn't. Negative 2.5 squared is positive, and it was treating it like negative. A much better number here. I got negative 18.75. So it looks like on this one, I'm going to have to change my vertical scale. I'm going to stick with 1, 2, 3, 4, 5, the way I've got it on my horizontal scale. I want to see this parabola. So I think I'm going to count 2, 4, 6, 8, negative 10 there, which means down here is negative 20. Now, obviously, if you change the scale, make sure you label your scale like I'm doing here. In fact, I should probably label both axes when I'm doing this. Otherwise, you might think that it's the same scale on both sides. On this horizontal scale, I want each grid line to be 1 unit. And then on this scale, I want 5 of them to be 10 units. So negative 2.5 and negative 18.5. Let's see, this is negative 18, so 18.75 is right about there. And then we know what the parabola looks like. We can see this thing stretching up like this, and we've got our graph. If this was class, I would pause and ask if anyone has any questions. All right, next example is kind of a mix of these two. I've got some different things happening, but one thing that jumps out at me is that I've got this x minus 5 and then that plus 75, which means my vertex is going to be at 575. Now, if you're looking at this and you're saying, what about that negative 3 over there, Mr. Crowett? I would say, good to notice that, but that's not going to affect the vertex. One of the things that you're going to learn about next year in pre-calculus is more transformations. Last week, we just did translating left, right, up, and down. And it turns out what this negative 3 is going to do to the graph. And we'll see this when we graph it. It's going to be stretched out vertically, and then this negative is going to flip it upside down. We're going to get a parabola that opens down instead of opens up. And I'll show you what I mean by that in just a moment. But anyway, that's my vertex. My zeros, I'm going to find the same way I did that other problem. I'm going to set this equal to 0. In fact, I'll just write this. If I set that equal to 0, I'm going to subtract this term over to the left side and then go down here for the algebra. So 75 equals 3 times x minus 5 squared. Divide both sides by 3 to get 25 equals x minus 5 squared. And then just like I did with the other problem, I'm going to say, well, if I'm squaring something and I'm getting 25, that stuff, that x minus 5, must be equal to either 5 or that x minus 5 might be equal to -5, because -5 squared would be 25 also. So let's see, x minus 5 equals 5, so x could be 10. Or if x minus 5 equals -5, then x would be 0. And so I'm getting zeros at 0 and 10. Is that a positive 10? Yep. Also interesting, well, not interesting, but worth noting, halfway in between the zeros, there's my vertex. So if I didn't know this already, given these zeros, I could have said, okay, well, if these are my zeros, vertex has to be halfway in between, so the x value is 5. And if I plug 5 into this, well, 5 minus 5 is 0. 0 squared times -3. I've got a whole bunch of 0 plus 75 brings me to 75. So as I'm drawing this graph, looks like I'll be able to keep that same horizontal scale going between 0 and 10. But my vertical scale is going to have to be stretched out. Let's make this go all the way up to 100. So then this is 50, and we'll be able to find everything else from that. So 5, and then 50, 60, 70, 75 is right there. And I've got the graph that looks like that. And so we've got this opening down of the vertex at the top of the graph instead of the bottom of the graph. And then it has this upside down parabolic shape that I will refer to as opening down. So there we go. That is how we'll do something like that. I don't think there's anything more I need to say about that. Well, how about this? We see this flipped upside down because of the negative, and then 3 is stretching it out. Now, it doesn't look very stretched out. Look, my scale, I'm going by tens on the vertical axis and only ones on the horizontal. So if I was going by ones on both axes, 75 would be way up off the top of my screen. Or if I went by tens on both axes, well, then 10 would be right here, and it would be almost straight up and down. It would be really stretched out vertically. All right, I'm going to take a look and see if any of my other examples are significantly different. I think these are all pretty similar to stuff we've already done. I'll maybe just do one more of these where we have to factor out. I'll do one where we have to factor out a negative. Again, this isn't my standard form. I don't have just like plus something tacked onto the end. I've got factors in common between these two. I'm going to factor out a negative 2x. And when I'm done, I'm left with x. Well, let's see. Negative 2 times what is going to give me positive 14? Let's go with a negative 7. And again, if you're doubting yourself, just redistribute that. Negative 2x times x is negative 2x squared. Negative 2x times negative 7. And there's our positive 14x. And in this form, easy to recognize those zeros. Negative 2 times what gives me 0? Well, 0. And what minus 7 gives me 0. So those are the two places where this graph will cross the x-axis. 1, 2, 3, 4, 5, 6, 7. There we go. My vertex is halfway in between 0 and 7. The x-coordinate is 3.5. And then once more, I'll plug this into my calculator. I'm going to use the second equation this time. I'll do negative 2 times 3.5. And then multiply that by 3.5 minus 7. And I get 24.5. And when I graph that, I'll have to change my vertical scale again. Let's see, if I want to get all the way up to 24.5, maybe I'll go by 3s. So the top of my graph with 10 grid lines brings me to 30. So let's maybe go 3, 6, 9, 12. I suppose 15 would be right there. 18, 21, 24 is right there. So just a little tiny bit above that. There is my vertex over 3.5, up 24.5. And with those 3 points, I've got a pretty good idea of what this graph is going to look like. Heading down in that direction, and this one also. Notice that this one also has that negative coefficient. Negative 2x squared makes this parabola flip upside down. It is opening down. I've got a couple other examples, but I think that's probably good enough. They're just more examples of the same thing. As always, if you're working through the assignment and things seem weird, if they don't make sense, certainly get in touch with me. You can ask me about it when we have class on Monday. And most of all, I hope you guys have a wonderful weekend. Stay healthy, stay safe. See you on Monday. Bye-bye.